Hey guys, so today we're going to go through another statics problem. This problem is coming from chapter 7 of the textbook, so once you guys get to that chapter, this might be able to help you. It's kind of like one of the most basic problems you'll do, but it's really important that you understand it because it has a lot of components that will help you later on with the more complicated problems. So let's get started. So this problem is asking about a crate with a mass of 60 kilograms, and then there's a force being applied to it. This picture actually comes with the written problem, so we know that that force is being applied at the angle of a 5, 4, 3 triangle. So that means that we know a lot more about the angles of the force and the way that that force will act on the x and y axes. So anyway, this force is a 200 Newton force, and then there's a coefficient of static friction of 0.3. So what we're doing here is we're calculating the maximum force that can act on the system without the system moving, and then from there that'll help us to tell the corresponding frictional force. Okay, so the first step is that we're going to identify the forces that are acting in the x direction, and we're going to find their value. So all of these forces are going to equal 0 because, like we said before, the system is currently not moving. So what's going to happen is there's that force acting in the x direction, and then counteracting that force is the x component of force P. So to find that force, we're going to plug in what we know, which is that P equals 200 newtons. And then we'll find the angle at which that P force is acting along the x-axis by multiplying it by 4/5. And then you just solve for F and you get 160 newtons. Okay, so then our next step is going to do the same thing, but to identify the forces acting in the y direction. So again, these are going to be 0 because the system is still at rest. But the forces that are acting in the y directions are the gravity force, normal force, and then again that y component of the P force. So in this case, we are solving for the outside force, the N, which is normal. But anyway, so we're going to do that by finding the force of gravity, which we're going to get by multiplying the mass times the force of gravity. And then also acting in the downwards direction is that y component of the P force, which we do the same thing that we did before, except we're multiplying by 3/5 because that is the angle that the P force is acting in the y direction. So then you just do some simple algebra and you'll come out with 708.6 for normal force. Okay, so now the last step, we're going to find what the problem is actually asking for. So the first thing is the maximum force that can be applied to the system without it moving. So right here you just have a simple formula, which is the force, the amount of static friction multiplied by the normal force will give you that F max. So when you plug all that in, you get 212.58 newtons. And then since we know that the F max has to be greater than the frictional force, we look at those two forces that we identified in the x and y direction, and we see which one is less than 212.58, and we see that it is the force acting in the x direction, and we know that that equals 160. So that is that frictional force that we were asked to identify. So that's it for this problem. Like I said, it was super simple, but these applications can be used in other problems that are going to be a little bit more difficult. So make sure you know this one really well. And then if you need any more help with problems that are a little bit above this, let me know and we can definitely work through them.